All right. Hello, everybody, and welcome to the stream. I hope everybody's doing all right tonight. We are live both on YouTube and Twitch. We are simulcasting between both. So tonight we are going to pick up where we left off last time, which was we're going to finish up the chunking stuff for terrain chunking, and we're also going to take a look at LOD tonight. So yeah, that's kind of what's on the roster for tonight. We'll see where we wind up after that. Leaguer Gaming, hello, and yes, Heartbound music. Yep, yeah. It's if you do exclamation point music, it's got a link there to the OST. In fact, I'll just drop that in here so that anybody coming in can see it. So yeah, the music is from Heartbound, which is a game in development by Pirate Software. And he has graciously allowed folks to use that on their stream as background music. So I'm going ahead and doing that because it's an excellent soundtrack. Highly recommend it. It's a fantastic game as well. Kodotaku, hello. Welcome to the stream. How are you doing tonight? All right, so before we jump into things too much, I wanted to just take a quick second and thank the supporters of the channel. Starting with the partners, they are the highest tier of subscription over on YouTube memberships and Patreon. They are Gabby Bashir and Gerbolis Inc. I'd also like to thank all the other supporters listed here on the screen. They are the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much. I appreciate the support. And I hope it goes without saying that I appreciate each and every one of you guys who hangs out with me on stream, whether it's here on the Twitch side or over on the YouTube side. I appreciate you guys very much, and any of you that are following along with this project. Greatly appreciate it. Okay, so last time we were kind of in the middle of trying to debug some stuff in terms of getting the terrain chunking to work. And so I just want to go ahead and mention that I did figure that stuff out rather than spending a lot more time on camera with it. And it was actually something that I totally didn't expect at all. So we'll be going over that. I'd also like to point out that we do have a website here for Kohi Engine. It's basically got everything, all the information about the engine and whatnot. So if you're interested in that, that is here as well. I'll drop a link to that in chat. But I'm going to use it to get over to the GitHub repo. And we'll go ahead and take a look at the terrain chunk feature branch, which is where we're at currently. And let's go ahead and take a look at these commits, right? So I think the last place that we left off was probably about here. I think it was work in progress terrain chunking 2. And actually, now that I see some merges here, there is something else I forgot to bring up that we should probably cover before I jump into this too much further. So you'll see some references in here to versioning updates and merge from v0.6.0. What is all this stuff? Well, we are going to be changing the way that we handle versioning and tagging and so forth. So let me actually open up a new tab here. So up to this point, we haven't really paid much attention to versioning of the engine, other than just sort of our little automatic process that kind of runs and gives us an automatically generated version in Kohi. And that's all well and good, but it's not really descriptive enough for a project of this size going forward. So I've changed up and refined the versioning process a little bit. And this is to line us up to start thinking about engine release versions, right? We were currently, with all the PBR stuff, the shadow map stuff that we've worked on, we were on version 0.5. And I've gone ahead and cut that as a version. And we're now going to be working on version 0.6. I also updated a couple of the screenshots here with the new PBR details. So let's see, do I have a link on here to it? I don't know that I do. So let's go ahead and look at the changelog. So you'll see here that we have version 0.5x, and this has got all of the changes that we've made, right? Now we actually have another version, which is called 0.6, right? And what we're doing is we're changing our branching strategy a little bit. So I guess let me pull up Paint, our good old trusty Paint, right? And let me swap the color on this just so I don't blind you guys at the same time. Okay. So we're going to be changing up the way we handle versioning. So up until now, we just had this sort of, this main branch over here. It's not a very straight line. Let me try that again. So we have the main branch here, and then we just kind of split off of that and do a feature here, right? And we do a couple commits along the way, and then we would merge that feature back into main. And then we do another feature, and we do a couple commits or whatever along the way, and we merge that back to main. We're going to be doing something a little bit different. So what we're going to be doing now is we are still going to have our main branch, but from this main branch, and I'll switch colors here, we're going to have a version branch, right? And so in this case, this is going to be 0.0.6. That's a terrible 6. Let me try that again. It's hard to draw with the mouse, all right? So, oops, that should be 0.6.0. Sorry about that. 0.6.0, right? And so what we're going to do is then take feature branches off of that, right? And so this will be one feature, and we'll do commits against this guy, right? And then it'll merge back into the 0.60 branch, right? Because it's associated with that version. And then we'll do another set of these changes, and it'll merge back into that, right? And then eventually what's going to happen is once we've done enough features where we feel like 0.6 is going to be complete, we're going to take 0.6 and merge that back into main, right? So this goes away, and we merge that back into main, right? And then at this point, we will tag this as version 0.6.0, right? And so what we've done before this, leading up to this, is we've done another tag down here for 0.5, right? And so this way we have everything that's sort of tied together. Main only receives basically release updates, right? So it's basically a whole bunch of updates that wind up going into the main branch from these version branches. And then once we cut this tag, we'll go ahead and cut 0.7.0, right? And we'll have feature branches off of that and so forth, right? And so part of the idea behind this, with all the tags and all the version branches and stuff like that, is these branches will basically be around forever in case we have to do a patch, right? So I'm not thinking this is going to be something that we're going to run into short term, but long term, eventually we're going to want to do a patch. Let's say that we've discovered some sort of bug. Let me pick a different color here. Let's go with orange, right? So let's say that we've discovered that there was some sort of bug that was introduced here, right? So this is a bug, right? And so it was introduced before 0.7. And we've made a whole bunch of changes in 0.7. We don't really want to necessarily wait until 0.7's release in order to fix that bug. What we could do is cut a new version branch in here and call that 0.6.1, right? And that would just include any bug fixes, right? And then we may still merge those same bug fixes into 7, right? But we don't have to worry about 0.7's release happening before actually getting this bug fix. So that's kind of the new versioning strategy that we're going to be using. Similar to get flow. Yeah, exactly. Will there be circumstances where you'll want to have two active versions receiving commits for a short time? Yeah, potentially. I could see it happening. Do I prefer merge or rebase? I prefer merge. For sure. So, yeah, that's basically where we're at. So, essentially, everything from here down was like our PBR stuff, right? And all the work that we're doing for terrain chunking is going to be in here, right? So that's really the first major set of changes, as well as some other bugs that I fixed, right? So I hope this kind of makes sense. All right, so with that, we do have, did I close it? Yeah, we do have a change log here that's been updated, all right? So we can see we've got a new 0.6.0 change log set here, right? And we've kind of talked a little bit about at least the high level of this stuff. So one of the things that is going to be changing is our full version number is going to be basically major, minor, patch, and then we're going to have a build-revision, and that's going to be that automatic portion that we had before. Let's see. I already covered branching strategy. Let's see. We've already covered that. We've already covered tagging. Okay. The other thing that I want to cover too is all of our libraries in code now have separate versions of their own. So the main version, when we're talking about version 0.6, right, that's an engine release, right? So the engine's library is going to be tied to this version, but that doesn't necessarily mean that the other libraries that we have are going to be tied to that. So what I mean is, if we take a look at engine, we now have a version.txt file that resides in here, and this is 0.6.0. This is where that version is tied from. And eventually this will be tied to like a CI process that runs that is a little bit more automatic. For now it's manual, but it's still good enough for right now. And so whenever we run our little version program, it pulls this as the first part of the version, and then it adds that automated stuff afterwards. And the important thing to note here is Engine has one, and if we look at some of our libraries, such as our audio plugin, it has its own version, which is 0.1.0. If we look at our Vulkan renderer, for example, it has one of its own as well, and that's 0.3, right? And the idea here is that we're eventually going to have separate change logs for each one of these, and we can manage all of those changes separately, right? Because we might have an engine release for 0.6, let's say, but maybe there weren't any changes to the audio library. So why are we going to create a branch for that, right? And eventually these will probably be split out to separate repos anyways. But for right now, that's kind of the direction we're going, right? So that everything has its own version, and that version is also echoed to the console whenever we load up. That way, whenever I get bug reports and stuff, at least from here forward, I can just take a quick look and see what the version number is of all the libraries and get an idea of where they're at in the code base, right? So let's see. Starting to really enjoy the clean history of a rebase, but under some circumstances it can lead to more complicated conflict resolution than simply merging all the time. Exactly. Yeah, and clean history isn't something I really want for this project, right? Because all of the merging and stuff, I need all that history for this. Just because there's so many people following along, in the video series and whatnot. They would be completely lost otherwise, right? All right, so that's the versioning stuff. I think, let's see, did I cover everything? Oh, so along with that, each one of these has its own version.txt. Each library also has, under source, oh, have I not built this yet? let me build this. Why are you just splitting like that? My build hotkey stopped working. That's rude. All right. Let me relaunch Vim. There we go. So one more thing about versioning to show real quick, and then we'll move on. Okay. So if we take a look, I guess I'll use Vulkan Renderer as the example. Let's see, why is it not showing? So we have this version.txt, right? For each one of these guys. For some reason, my H files aren't loading. Did I do this in a different branch? Am I on the wrong branch? I might be. Let me switch to 0.6. Okay, I do have everything latest. Where are my version files? There we go. I think it's working now. Okay. There we go. So we generate these version H files, right, which has our generated number in it. And that is used in code to actually spit out the version number that's compiled into the library. That's all I was just trying to show there, right? All right. I guess that change probably hasn't made it into our terrain branch. Let me just see what this stuff is. I'm going to stash this change because this was something else I was working on. All right, let me go into terrain chunk. It is already up to date. Okay. I guess. I just needed to clean and rebuild it. Okay. So yeah, switching back and forth between the new versioning system and the old versioning system gets a little bit weird sometimes. So I shouldn't have to do that going forward, but yeah, it gets a little bit weird. Okay. So with that, I guess let me launch the engine just so that I can show you guys where we're at. All right, and I'm just going to pull this down so that you guys can see this. Before I load anything up, though, let's pull up the console. And I'm going to go all the way to the top. And so now you can actually see our version info is displayed in the log, right? So all of our plugins that we load, we have the versioning information for that. So I can tell from this kind of how far along they are in the code, and I can tell from this when it was built. And so they all kind of follow that same pattern. They all have their own independent version numbers and so forth. I think standard UI is a little bit further down, if I remember correctly. So that's, and then testbed also has its own version, right? So that's that. And then if we actually bring this back and load up the scene, it doesn't look like it, but we actually do have terrain chunking working here, right? So I did get it all figured out, so we'll kind of step through what that is here in a moment. But yeah, we do have all of the terrain chunking stuff worked out. So we should probably step into that, which means I actually need to change branches here. All right. And actually, our changelog here reflects some of the stuff that I did. So we added terrain chunking supports, and then I fixed an issue with D-arrays that could cause an invalid header data in certain scenarios. And this is a bug that's been in there since I first wrote D-arrays that I didn't realize was a problem. And then the simple scene queries were actually the root of all of our, like all the offset errors and stuff that we were getting before, and the sort of invalid memory. This was the root of all of those problems. So if we take a look at, actually, don't we have an index up here I can skip to? I thought we did. Does it not? Yeah, here we go. So if we take a look at, it would be simple scene. I'm not seeing it here. There it is. Look at the header file. So all of these functions here where we're performing queries, right, for mesh render data and for terrain render data, these were just taking in a flat array of out terrain geometries, which is fine if the array never had to resize, but if it did, then the address of that array would basically have to change, right? And since this pointer is basically passing the array by value instead of a pointer to that array, that was a problem, right? So basically we were losing the new array after we created it, right? It was only getting stored sort of locally, and then the address of that wasn't being maintained because we were passing the address of that by value, not by reference. So what we needed to do here is actually have a pointer to the array here, so that if we had to resize the array as we were pushing entries to it within the function, it would actually, write out to the correct place. So that solved like 90% of the problems that we were having, right? It had nothing to do with vertex or index buffer layouts or any of that stuff. It was purely because we were basically picking up trash memory because we weren't doing this correctly. And that trash memory had, numbers that were super astronomically large and, of course, out of the range of what we were expecting. And so that was probably the biggest fix. The other commits, let's see, we had various bug fixes. I think this was, we fixed extents generation for terrain chunks. This was another issue because we had improper frustum culling happening. So basically what we were doing was, where is it? This is how we were calculating the extents before, right? So we were basically just using the terrain extents min and max y to generate this, which wasn't actually set. So the terrain's extents min max y were both 0. And so what we were getting was we were actually getting extents that were generated way below the actual point of the terrain itself. So what we're doing instead is as we are iterating the chunk, and as we are going through, let me expand this a little bit. As we are going through the vertices for that, we are basically taking a min and max here along the way as we go on the y-axis. And that gives us an accurate extent for that region, right? So we take that in addition to the first vertex and the last vertex position, and we get extents that actually make sense. So that was another issue that we solved. Also, we had a couple of issues where we had done some I'll come back to that actually, because that's another change that I made separately. We also killed this dead code, right? So that was another thing. If we look at this list here, let's see. We also changed, let's see. Yeah, we changed the shadow map pass to query scene geometry once. We were doing it per pass, and that was kind of unnecessary because we're going to be using the same geometry no matter what, because we're not actually culling per pass, right? We have to render everything always. So this is the change from that. And then also we added a simple scene terrain render data query from line, like we were doing with the geometry. We now added a terrain version of that so that we can use the line of the directional light to get distance from line and see if we need to cull it that way. It's a little bit cheaper, right? It's a lot cheaper, actually. So there's that. And then basically, instead of going through each cascade and querying, we basically just query once at the top and we're done, right? We don't even need this loop. Like, the entire thing is dead now. So that's that. And then there was one other big change that I made in 0.6, which I actually don't see here, that I do want to go over. Let's see, where is that? Did I forget to actually add it? So if we think about the work that we did before, this is under various bug fixes again. We did some work before about the various scope binding. We changed some of that stuff, and there were just a couple places in here that I forgot to bind and apply, like locals, for example, and I forgot to bind globals here, so that was just fixing a bug for that. And then one last thing, and then we'll just kind of move on, right? I guess I didn't finish that yet. I should probably get that in at some point. So one other thing that I've kind of worked on the side, and I'm just going to very briefly touch on this, is let's see. Basically, are moving all of the uniform logic out of the Vulkan backend to the front end. And the reason that we're doing that is because all of that logic that happens, let me find it. All of this stuff, actually, nope, that's not it. All of this stuff, like where we're setting uniform locations and stuff like that, we are kind of passing all that to the back end to be done. And there was no Vulkan specific logic in there, right? So we're moving all of that to the front end. This branch isn't 100% ready to go yet, but I just kind of wanted to give that as a preview of something that's coming as well. So the advantage is here is we're not going to have all that repeated code and multiple rendering backends. We're just going to have it in one place, right? So there's that. Let's see. And I think that actually is going to do it for right about now. And we're going to get into the LOD stuff, right? Because I think I've covered everything I need to cover in here. I will briefly touch on our loops that we were looking at before that was wrong, right? Where our data was just kind of wrong. But I'll do that after ads. So for those of you who are new to this stream, on the Twitch side, we're served ads once every 30 minutes for 90 seconds, or up to 90 seconds, I should say. So I'd like to pause the stream whenever that occurs. I know you folks over on the YouTube side don't get those ads, but over on the Twitch side, they do get them, so I don't want anybody to miss content, right? Let's see. Speaking of the YouTube side, Ron Diaz, hello, welcome. How many days are you working on this project? Days? I don't know if I can quantify that. It's been years, actually. It's been a couple years. We're getting ready to hit our 30-year anniversary, actually. Which sounds like a lot, but it's not all that much considering I can only work on this part-time. Not even part-time, really. It's like my spare time, right? But yeah, it's been almost 3 years that we've been working on it so far. So I don't know the exact number of days, but I hope that answers your question. All right, so we got about 5 seconds left on ads. All right, and ads are dead. Okay, so ultimately this is our terrain chunk initialization code, right? So we stripped out a bunch of the old dead code, right? A lot of the index and vertex generation code didn't really change. Just some of the size dimension stuff did. So for the vertices, we loop through what we're considering the chunk dimension, which is the chunk size plus 1, right? Because you've got, for 16 tiles of data, you've got 17 rows, right? Or 17 columns. So that's true in both directions. So we plus 1 that. We loop through that, generate our vertex information. And then we go ahead and grab the height data from that flat array of height map data. We go ahead and we take the min and max from that, as I talked about before. And then the index information is basically the same, right? I did a minor optimization here, and instead of reaccessing this array every time, I just saved it off to a local variable and plugged that in there. Calculation of the extents updated, we've already been over that. And then the index information, right? So there's not been a whole lot of change here. One thing that I did do is take a lot of sections of repeated code like this and split them out into variables so that it's a little bit easier to read. And then, of course, instead of going terrain indices, we're doing chunk indices, right? We also wait to generate normals and tangents until we're done generating all the data for the chunk. And let's see, is this even... I think we've really pretty much covered everything else here. All right, so yeah, we've covered everything else here. All right, so what we're going to talk about tonight, because we have the, let me run one more thing here. Let's see, I'm going to set a breakpoint. Let me see, let me do scene pass. Okay, so let's see. Terrain geometries. So we're looping through our terrain geometries. I think I need testbed main, actually. Prepare frame. And we'll look at the scene pass. Specifically, the section of logic where we are gathering our terrain geometries. Here we go. So let's do right here. Let's do a breakpoint right there. Actually, wait a minute. That's the shadow pass. That's the wrong pass. I want to do... I want to do here. Okay. So what this is doing is we're sort of setting up a small array for our terrain geometries, and this is to feed to our scene pass. We calculate, or we query rather, the simple scene to say, hey, how many terrain geometries are actually visible by our view frustum? And then looks like, are we getting, why are we getting 256? That doesn't seem right. Let's step into that real quick. So we have one terrain. Here's our chunk count, right? 256 is our chunk count. We do have a frustum. Okay. So the geometry is the chunks geometry, all right. Let's see, our half extents. Oh boy. That doesn't look like it came through correctly. The y-axis didn't come through correctly. So we might still have some bugs there. So our center does look relatively correct. I'm not so sure about this y-axis here. But that's transformed. Let's see. What does the... Oh, it is moved down 3 units. Okay, so I guess that is correct. So if it intersects... It looks like it's failing all intersection tests. So we might have some work to do on the culling of that. It looks like everything's passing for right now, which is not necessarily correct. But I'm going to disable this for right now. So we may have to come back and fix that, actually, because I hadn't really had a chance to test that. It looks like our culling of meshes is working right, just not the terrain, I guess. Because it never drops below 256. If I position this there, you can see it there. So it looks like it's drawing every piece of terrain, which is unfortunate. So I'll have to figure that out. I'm not sure why that's... Not 100% sure why that's failing. Let's see. Shadow map pass, which I think it was right on the shadow map pass, but not the actual view pass. Or the scene pass, rather. So we are going to have to figure that out. So this is the mesh query. And then this is the terrain render data query. And it's using the same parameters. Curious indeed. All right, well, I'm going to slap a to-do on that. We'll come back to it later because it's not really relevant to what we want to talk about tonight. maybe we'll revisit that later. All right. So what we want to talk about tonight is LOD. So we have our terrain, right? And you'll have to excuse the guaranteed to be terrible drawing here. And so our terrain is split up into chunks. This is what we've done to date, right? So I'm just going to split this up a few times. Right? So we'll say here that we've got 16 chunks, right? And then within each one of those chunks, we have a certain number of tiles, right? So, this chunk maybe is split a bunch of times, right? In fact, let's make this really small to illustrate my point. All right. Mug9, thank you for the follow. Appreciate that. Welcome. All right. So we've got something that looks like this, right? Really semi-densely tessellated, right? And so this is all well and good if our camera is like here, right? Looking at it like that, right? That's nice and close to the camera. It makes sense to render that in full detail. But what about all the way over here, right? What about this guy, right? It doesn't make sense to have that kind of detail rendered over here, right? So how could we, in theory, accomplish rendering this a little bit different of a way? Well, if we think about the way that each one of these individual little tiles is rendered, right? We have 4 points, right? And so what I'm going to draw here is a 2x2 grid, right? And so each one of these spaces is basically formulated. Oh God, this drawing is terrible, but I think you guys will get the point, right? By 2 triangles, right? I'm just going to do this really quickly. All right. So if we start thinking about how we might want to reduce the detail on this, if we look at this closely, what do we actually see when we look at this, right? When we look at how this is split up, right? We see that our triangle information is just kind of, it fits a pattern, right? So we have this one, whoops. We have this point to this point, this point to this point, this point to this point, right? And then we have this point to this point to this point to this point, right? If I can draw that a little less crappy, that'd be great. All right. And so all of these fit that same pattern. Now, if we wanted to reduce the number of these, we theoretically could do some math and just upload less vertices, right? And less vertices would basically just give us, less triangles, therefore less detail. But we don't really need to do that because when we talk about how these are rendered, we render these using indices, right? And so we say, well, we want to use this one, and then this point, and then this point to form that first triangle, and then we use this point again, and then this point, and then this point to form the second triangle. Well, what if we started skipping data a little bit? What if instead of doing it this way, right? What if we did this one, then this one, then this one, right? And then this one, and this one. That would give us something different entirely, right? That would give us essentially a fraction of the same triangle data using the same vertex data. We just skip vertices, right? Now this is an example that's relatively simple because it's only a 2x2. But if you start thinking about this on a 16x16, which is what our current chunk size is, there's several layers that we could do this, right? So our first LOD, I'll do this in green, would basically give us a grid. Let me see, can I go any thicker on this line? No. It's already thick with 2 C's. All right, so if we zoom into this guy a little bit, right? If we say that green is our LOD, our second LOD level, right? So white is our LOD, we'll say white is LOD 0, right? That's our base LOD. Green is our LOD 1, right? We would basically wind up with a grid that looks like this, right? So basically a quarter of the geometry already, essentially, right? And then if we took our next LOD and we say our next LOD is 2, then that grid would look something like this, where we only have 4 squares, right? And then we can actually split that up one more time and say, well, what about level 3? And level 3 would just basically be this. And we can achieve all of this just using different sets of vertices, right? And so basically what we're going to do is, we're using the same set of vertices, rather different set of indices. So we're going to have multiple sets of indices, and we're just going to change which set of indices we use and draw with, and that will give us our LOD. And so what we're going to do is we'll implement that portion of it first, and then we'll go ahead and from there, we'll probably put in like a hack into the engine really quickly where we can just kind of quickly toggle back and forth it, just to see the different LODs. And then we'll actually adjust which LOD level we are using based on the camera's position away from it, right? So that's kind of how we're going to achieve this. Now, theoretically, if we wanted to, we could also take this in the sort of opposite direction, right? We could call this a -1 LOD, but really we just shift the scale this way, right? And we could tessellate, right? Which would basically mean to take the data that we have and just jam more vertices in there, right? And have that be our new 0, right? So that's something, tessellation is kind of a separate thing. That's something we might also look into, where we can get a much more rich terrain that's a little bit more evenly blended by doing that, right? But we'll cross that bridge when we come to it. So, in terrain, we have currently vertex count and vertices, and index count and indices in each chunk. So what we need to do is we need to peak definition on this, and we need a way to essentially have a set of data for each one of these, right? For each LOD. And so what we can do is, let's say, type def, a new struct. Maybe Tall, thank you for the raid. Welcome. How are you doing tonight? What are you working on? What are you up to? We'll do terrain chunk LOD. LOD. And I think what we'll do here is we'll essentially have these. And I think we're going to need some additional info regarding the geometry, right? So if we peak definition on this, one thing that we have is these different sizes to keep track of. And right now this is kept on our geometry data, but maybe we need to keep it on our LOD data and use it there instead, right? Hello, I'm good. How's your stream? It's going good so far. Thank you for asking. You're working on a game in Godot. Awesome. I'm going to toss you a follow and a shout out. So there's a shout out to Maybe Tall. And I will check out your stream next time I see you on live. Online, rather. On live. All right. What are you currently working on? So we are working on a game engine that we're building from scratch using C and Vulkan as our initial rendering backend. Right now, we're specifically working on implementing terrain LOD, so level of detail on terrain, right? And we were just kind of going over our implementation of that. Anonymous Gifter, thank you so much for the gifted tier 1 sub. Appreciate that. So, yeah, that's basically what we're working on right now is kind of how we're going to implement that, right? And we're basically going to implement it by skipping vertices. So we've already done terrain chunking. So we already have all of our terrain, sort of split up into chunks. Now we're going to LOD those chunks, and then eventually we're going to set it up so that we'll have different levels of LOD based on how far away the terrain is from the camera, right? Okay. So, let me just double check. Over on the YouTube side, Sing Yi, hello. Welcome. Good to see you. All right, so currently the way that this works right now is our geometry has vertex data and index data that gets uploaded against it. And then when we go to render that data, we essentially take copies of the index element size, which is just the size of each index, an array of indices, and the index buffer offset. So that's where in that buffer the actual index data resides. And so we're going to have to kind of finagle this a little bit. And we're going to need to update or upload index data outside the context of a geometry. We're going to reuse the vertex data, and we're just going to have new index data. So what we're essentially going to need is a copy of this stuff. And we're going to need that here within this structure. Oops, not in terrain chunk, in terrain chunk LOD. All right, so we've already got index count. I guess I could just move the comment up for that. We also have the index data, so we don't need that. And then we have the index element size and the index buffer offset. So essentially each terrain chunks LOD is going to have its own set of index data that's going to have to be uploaded to that buffer separately. And then when we go to render the geometry, we will choose the current LOD that we're on and render that. Is this open source? Yes, it's 100% open source. So let me pull that up real quick. So I'll drop a link here in chat for you guys. I guess I could give the quick introduction real fast. So we actually have a website for this. The engine's called Kohi. So it's basically a play on the Japanese version of the word for coffee. Just because I'm a coffee nut, I love coffee. And the website is kohiengine.com, so we've set that up just as sort of a hub, a central hub for the engine project, with links to like the YouTube and Twitch, Patreon, GitHub, all that stuff. If we take a look at the GitHub, right, it is 100% open source and it's Apache 2.0 license, which what that means is if you want to use this code, all you have to do is say that you use the code. That's literally it. There will never be any royalties. There will never be fees or licensing of any kind aside from just the license here. It's 100% free and open source for whatever you want to use it for, right? Because this engine's being developed as a educational exercise, and I believe that education should be free. This knowledge should be free. So I'm basically trying to build the resource that I wish I had when I was learning how to do this stuff, essentially, right? And so that's just kind of the idea, right? It's free, it's open source, it's a learning resource, and I hope it's useful, right? Spiro, hello, good to see you. How's it going? How many 24-hour streams have you done lately? A lot. I'm gonna give a shout out actually to Spiro. Spirodon is working on a pretty kick-ass project that is using WASM, Zig, and using the HTML DOM as his front-end renderer, right? It's pretty sweet stuff. There we go. You might do another one. You are crazy, sir. Yeah, he likes to do these super long streams. So it's kind of insane. But his content's really good. It's a very wholesome stream. I like to watch it whenever I can. So don't know anything about Zig, but WASM is super interesting to me. Exactly. I'm kind of in the same boat there, right? But yeah, he will. I'm sure if you ask him next time he's online, he'll give you sort of a brief rundown of what he's working on. It's really cool stuff. Definitely really cool stuff. I highly recommend checking out his stream for sure. Master Snoods, thank you for the follow. Appreciate that. Spiro, thank you for the shout out. I appreciate that. All right. So yeah, basically, this is a free and open source project. We're implementing almost everything from scratch. There's a couple things that we kind of took shortcuts on in terms of like image loading, font loading, things like that. But for the most part, we're writing everything from scratch, right? That's just how we're kind of doing it here. This is implemented with a plugin architecture in mind. So the engine itself is a shared library. The application consumes that. So we have a testbed, which is an application, right? An editor would be another example of an application. That has its own library of code, which is a shared library and is hot reloadable. And then we have other plugins, like the audio system is a plugin. The renderer itself is a plugin. So the renderer right now is our Vulkan renderer. It's the only plugin we have, but eventually we're going to have one for Direct 3D as well as Metal. And so those are plugins as well. Our standard UI system, which is the UI system that we're standing up from scratch, that is also a plugin, right? So the application can fully choose what it wants to use and what it doesn't want to use, and go from there, right? So that's kind of the way we're building this whole thing. And so right now we are working on terrain LOD, which is level of detail, right? So it's just it's an optimization that you need for any terrain that's going to be of decent size, right? Okay, so with that, our chunk no longer includes index data, right? It's going to be our chunks LODs, essentially, that are going to include that. So let's see. I think probably the best way to do this is going to be... Let me take a look at something in my image loader. I need this function, because this is what's going to also do the same thing in terms of telling me how many levels of detail I can have. So the number of detail levels, LOD, is calculated by taking the largest dimension, either width or height. That doesn't really apply. And then applying it to ads, because we have ads. So for those of you who are new to the stream, whenever ads come up on Twitch, which is once every 30 minutes for 90 seconds, I like to take a pause on the stream just so that nobody misses any content, right? And I do that because you know, I don't want anybody to miss stuff that's going on. It's really hard to see that little tiny screen up in the corner, and of course you can't hear what I'm saying if ads are running, right? So I don't want anybody to miss stuff on a programming stream. It's kind of important that you don't miss stuff, right? So we like to pause the ads for those 90 seconds, and it also gives me a quick chance to hydrate. So there's that. Over on the YouTube side, I know you guys don't get ads the same way that Twitch does, but I just like to pause the stream across the board just so that, you know, nobody misses anything, right? So let's see. Lando Calrissian. I love the name. That's awesome. This coding stream is nice. I appreciate that. Thank you. Gives good ideas. Appreciate that. Programming, very cool. All right. Appreciate that. Thank you for the kind words, guys. Just a couple seconds left on ads. And ads are dead. Cool. All right. So basically we take the largest dimension, whichever is bigger, which is the width or the height. In this case, they're going to be the same, so we can actually skip that step. We want to use... config chunk size as that number, right? So we take the dimension, and then we figure out how many times that number can be divided by 2. We take the floor value of that, which rounds down, and then add 1 to represent the base level. And then this always leaves a value of at least 1. So this is the same algorithm that we use to determine bitmaps on our textures. It's actually the same thing, right? So we can say U32 LOD count, right? And that's our LOD count. So what that means is we can then take that. We probably ought to save that off to the chunk. Should we save that to the chunk or the terrain? Because every chunk is technically going to be the same. If we have a lot of chunks, that's a lot of memory, right? So maybe I'll save it off to the terrain. Because every chunk is going to be the same size. So I think that makes sense. So let's see. Right after we have chunks, let's put U32 LOD count, right? Thank you guys very much for the follows, by the way. I appreciate that a lot. It definitely helps, right? Trying to reach as many folks as I can in terms of this being an educational resource, right? So all the follows and stuff definitely help. All right, so let's get rid of that pane there, and we'll say out terrain LOD count. All right. So we've got that. We can use that. Which actually we only need to do this once, right? We don't need to do that every single time. So let's do that here, right after we copy over the chunk size, right? That makes sense. And then within each chunk, we will go ahead and do a chunk. Did we not create LODs on that? We did not. Okay, so we have the vertex data. We need the terrain chunk LOD. We need an array of those. And we'll say LODs. I guess is what we'll call that for now. So chunk LODs equals kallocates size of terrain chunk LOD times out terrain LOD counts, and we'll tag that as an array. and then we'll loop through that. So for U32, let's go with, I guess we'll call this, L looks too similar to I. I'm going to go with, I'm just going to call it LOD, right? Actually, no, I'm not. I'm going to call it J. J is less than out terrain LOD count plus J. And then what we'll do is terrain chunk LOD pointer LOD equals the address of chunk LODs sub J. Right, and that way we can modify that directly. Let's see, what do chunk and terrain mean in this context? So, I haven't built this yet, so I might actually still be able to run it. So we load up a test scene here. So we have this pretty big terrain, right? I mean, it's not the most gigantic thing, but it goes beyond the clipping plane. You can see it kind of clipping back here, right? So this is the terrain that we're currently dealing with, right? It's not highly detailed per se just yet, right? But this is what we're dealing with. And then the way that this is set up is the terrain itself is actually split up into what we call chunks. And those chunks are a certain dimension of the individual tiles. So if we look at the way that a terrain is generated, generally speaking, we have individual tiles for the terrain. You can kind of see where the outline of one might be here, right? And so, where'd my paint go? Here we go. And so for this example here, if we imagine that our entire terrain was much smaller than it is on that screen, right? If we imagine that this guy is the terrain, excuse my non-scale to scale drawing here, right? So the orange box is a terrain, and then these green boxes here are chunks, right? So we split the terrain up into some number of chunks that are evenly sized, evenly divisible, right? And then each of those chunks represent a certain number of tiles within them. In our case, it's 16 tiles by 16 tiles, which is obviously 256, right? And so the reason that we do this is because if we have our camera that is positioned, let's say the player is positioned right here, right? And our camera is looking out this way, for example, right? We don't necessarily need to render anything that is not within that view cone, right? So all of these chunks right here don't need to be rendered, right? But anything that intersects with this does, right? So that would basically be all these, right, need to be rendered. So it's an optimization. And then within those chunks themselves, we are optimizing it further to reduce the amount of rectangles that we actually draw or tiles that we draw, the further out it gets, right? So really close to where the player is, you'll have a really tight grid, right? You'll have the full detail of all the tiles, right? And again, this is not to scale, but further out, you might have half of that per se, right? And then really further out, half again, perhaps, or maybe it's just one, right? And so that's kind of what we're doing, right? That's terrains, chunks, and LODs. Is essentially what we're working about. Let's see. I'm about to learn about quad trees and a bunch of other trees this week, so this is useful and fascinating. Yeah. So actually, quad trees are something that I am going to be implementing for this soon. So at least right now, we don't have a quad tree implemented, but we're going to be adding one very soon, a quad tree and an oct tree. But for right now, the way that I'm planning on setting these is just with thresholds, right? So I'm going to use the center point of a of a chunk, right? And say how far away from the camera is that? And then, if it's past a certain distance, we'll use a different LOD for that, right? And that's kind of the way we're gonna handle it, right? We'll just take a distance from each one of these. That's a fairly cheap check, right? And we'll say how far away is that, and then set up some thresholds to actually switch the LOD out on that. So I hope that makes sense. That's the plan anyway. And obviously we'll refine this as we implement more, but that's kind of the idea for now. Once we have a quad tree, it'll be much faster to do this, right? We won't have to do all those distance checks. We can use the quad tree to speed that up, but okay. This is very helpful. Good. Okay. Awesome. All right. So for each of these LODs, we basically need to do this. So instead of the chunk owning these things now, the LOD does. But depending on the LOD that we have, the index count is going to be changing for that, right? So it's not necessarily going to be this. So basically what we're going to do is for each LOD, we are going to cut the amount of geometry by a quarter, which means that we need to essentially cut the dimension by a quarter. And that should give us what we need for each individual one. So let's see. The way that I would need to do that is, let's do a U32 dimension equals, let's see. I'm thinking out terrain chunk size times J times 2. And then we do dimension squared essentially. Right, so for LOD 0, which is our top LOD, this is basically going to be unmodified, right? And this needs to be divided by, actually. But that's going to give us a 0. We don't want to do that. Let's do... So we want to divide by this amount. Do we want to do... Do we want to take the inverse of this and multiply it by it? So if we do... (1.0) over that. Oh, that could still wind up being... No, that's not what I want. So basically what we want is LOD 0. We don't want it to modify this at all. So I could put a if condition in there, but that just feels dirty. LOD 1 would turn this into 2, which taking 1.0 dividing by 2 would give us 0.5. Multiply the chunk size by 0.5, and then you have your half dimension, right? And then for 2, that would be for... Yeah, so I think that makes sense, but... How do I get around that divide by 0? Let's see. And support LOD for meshes on the terrain, and dynamic loading and unloading of meshes when the chunk they belong to is loaded or unloaded. Yeah, so dynamic loading and unloading is definitely something we're gonna be handling, but not right away. Right. For now, we're just gonna basically be calling them, because we don't have geometry streaming yet. So I've not really got a good reliable way to do that yet. So for now, we're just going to be implementing the physical LOD portion of that, and then as far as streaming them in and out, that'll be another enhancement, right? That we do probably later on. That'll be really important if we wind up having terrains that are like kilometers, several square kilometers large, right? But yeah, asset streaming is definitely something we're going to have to do. It's just we're not there yet. And then mesh LOD is also something that we need to implement, although it's not quite this simple with like regular static meshes, because just skipping vertices might not always have the effect that you want it to have, right? Because those meshes are not cleanly divisible like these guys are, right? And so it may not and probably won't work out the way that you think it would or should. All right. We're probably going to need to take this whole thing and convert it to U32. I mean, I suppose we could just cast it away, or maybe I should take... Should I take the floor or the ceiling of that? I guess it doesn't really matter, because this is always going to be cleanly divisible anyways. I'm not going to worry about it. I'm just going to truncate it, right? So I guess I can do... This feels dirty, but I'm going to do it anyway. So I'm going to say if j equals 0, then I'm just going to use the out terrain chunk size. Otherwise, we'll calculate it. Right? And then, of course, LOD index count goes there. And now we have our index data. Or at least our array for our index data. Okay, yeah, that should be good. And then when we actually go to load it up, we'll go ahead and fill that out. But at least for now, it will be everything will be allocated. So in destroy, this is going to be another step now. So we'll say if chunk LODs, and we'll do a for loop here. So U32, j equals 0, j is less than chunk. Actually, it's going to be terrain LOD count plus I. Whoops, plus j. Caught myself there. And then take this, put it there, right? This is going to be LOD. We want terrain LOD is the address of chunk LODs sub j. Do indices, whoops, LOD indices, and LOD index count. So we'll free that. And then once we complete that loop, we'll do a k-free chunk LODs and size of terrain chunk LOD times terrain LOD count memory tag array. All right, so we'll clean that up. And I'm not going to bother zeroing out any of that stuff because all that stuff gets freed anyway, so not going to bother with that. All right, so that's destroy. Initialize. We did have some bugs in here with the min and max, so we may have to revisit that and fix that, but I'm not going to worry about that just yet. What we want to focus on for right now is the indices here, right? So what we are doing is we're generating 6 indices at a time and then bumping through the array 6 at a time. That's not going to change. What is going to change is this row increment and the column decrement per LOD. And I think that's literally going to wind up being multiplied by 2 for each LOD. Or maybe just multiplied by the LOD index, right? We'll have to see. So instead of generating indices at one level, we'll have to iterate our LODs. So let's see. What do I want to call this? We already are using I guess I can use J again. J is less than T LOD count plus J. And we'll go down here and add that. And then before this guy, we will say terrain chunk LOD equals address of chunk LODs sub J. Right? And now, instead of chunk indices, it's going to be LOD indices. All right, so that makes sense. We are going to have to think about this loop, this inner loop a little bit, though. All right, so what I'm thinking. So this is essentially the logic that we need for the base level, right? We want to loop through every row up to chunk size. And then we have row and column. We use that to get the vertex indexes, right? The index into the vertex array. And that's what we use right here. So the way that I'm initially thinking about this is the way that we increment row and column is going to be what changes. So for the first LOD 0, we want to increment by 1. For LOD 1, we want to increment by 2. For LOD 3, we want to increment by 4. Yeah, that's what makes sense in my head. Okay. Let me think about this for a second. So is it literally just +1? Can I get away with that? I'm going to do that for now. So we're going to do row plus equals j plus 1. And then column plus equals j plus 1. We want the I iterator to remain the same because that's the iterator into the index or the indices array. So I think that might be right. The only way we'll know is when we run it, right? In my head, at least, this makes sense. Okay, so we have that. We need to generate normals and tangents. Normals and tangents. I think normals and tangents for lower LODs, I'm okay with. No, I think we'll be fine. We just basically need to do this on the first LOD. So this needs to be chunk LODs sub-0 index count. LODs sub-0 index count. And indices. We only want to generate that generate based on first LOD. Others should naturally interpolate as verts are skipped. Okay, I think that makes sense. Ricochet the Yar bongos. It's one of my favorite emotes. Yar bongos. All right. So we've done that. We should have all of our vert and index information set up. Now loading becomes a thing. Because we have a render geometry create. Which is going to fill out the geometry structure based off of a set of indices and a set of vertices. So I think when we go ahead and do the render geometry create, it's fine to go ahead and base this off of the first LOD. And then the other LODs will essentially just upload the index information individually. So LODs sub-0 dot index count and dot indices. Leaguer Gaming, you got it too. Yeah, Yar bongos. I think we're about to have ads here in just a second, so I'm going to think here just for a second. So we create and we upload that. And we need to upload index data for all other LODs. base geometry off LOD level 0. Right. For U32, I equals 0, I is less than LOD count, we have adds. So, for those of you who are new to the stream, whenever we have ads, I break the stream just so that nobody misses anything. I know on the YouTube side, you guys don't really have ads that work the same way, but on the Twitch side, we have ads that are served every 30 minutes for 90 seconds, and then we can kind of continue, right? So we just need to get those out of the way, and then we will move on. Also gives me a chance to hydrate. So we got about 30 seconds left on our ad break, and then we will continue. Almost there. All right. I think ads are just about done. Yep. All right. Ads are dead. I do want to remind you guys, by the way, this is an interactive stream, right? So like if you have questions or comments or anything, you just want to chat, feel free to jump into chat. You know, I do watch it on both sides. Problematic Goonbag. I love the name, by the way. First time chat, welcome. Hey mate, found you through YouTube Shorts, loving the content. Awesome. I'm glad you did. I guess my YouTube Shorts might actually starting to work. I've been trying to put YouTube Shorts out now with, you know, clips from streams and stuff like that. So that validates that works. Thank you. I appreciate you letting me know that. That's awesome. Cool. And welcome. All right. ComCube TV, thank you for the follow. Appreciate it. Welcome to the stream. All right, so upload index data for all other LODs. Now my question is, do we have vertex update, but I don't think we actually have a method exposed from the renderer to be able to do this. So we're actually gonna have to write that real quick. No big deal. So we're gonna head to the renderer front end. And because that's actually where all this stuff lives, I won't even have to touch the Vulkan renderer at this point. So let's see. We actually have a couple things here. So we have render geometry creates, render geometry upload, and then we have vertex update, but we don't actually have a way to like manually update vertex and index data. And if I'm going to do one, I probably ought to do the other. So ultimately what this is going to need to do is we're going to have to provide it and say, okay, so here is the vertex data, the block of vertex data. Here is the size of each vertex, and here is the number of vertices we're giving you. Give me an offset into the buffer as to wherever you wind up putting it. And we're going to have to do that same thing for vertices and indices. So I'll put this above the update because I think that kind of makes sense. We are going to export this so that our libraries can all access it. And let's see, do we want... I guess we should probably indicate failure or success. And we'll do renderer vertex upload. Upload? Yeah, I guess that makes sense. And so we're not going to do this with the context of a geometry, right? But this will actually give us a little bit of a more flexible API too, actually. So what we'll do is we'll basically do this here. Right, so we'll do our vertex size, our vertex count, and then our array of vertices. And then we'll do a U32 pointer, and we'll say out vertex offset. Right? And I'm actually going to be a little bit lazy here and copy pasta this comment because it has like 90% of what I need. And so we're going to say uploads vertex data and returns and provides an offset into the vertex buffer. We don't have geometry. We do have vertex size and vertex count and vertices. We don't have these, but I'm going to hold on to those for a second. And then we return true on success, otherwise false. Okay, so I'm going to literally take this and copy paste it. And we're going to create a index version of that. So this vertex one, I'm going to delete these. The index one, I'm going to delete these. Right, so just the same thing, but the index buffer. We might eventually want to maybe expose the render buffer itself and just provide that. Actually, I wonder if we already do that and I just forgot about it. Render buffer bind. Map memory. Flush, read, resize, allocates, free, clear. Aha, we do have this. So actually, I don't even have to do that. Because I think this render buffer type, I think I might actually have what I need without adding that stuff. I just forgot. Render buffer type, vertex and index. And it will give us a pointer to a render buffer. That is what I need to do. So I'm going to undo all this other crap I did here. We don't need that stuff. What we really need I think it's render buffer get, right? Yeah, this is what we need to do. Okay, so let's go ahead and grab the index render buffer. So we'll say render buffer index buffer equals renderer renderer render buffer renderer render buffer get, and then render buffer type index. All right, we don't need this anymore. We can get rid of that. All right, so we have the index buffer. So I guess we'll say render buffer. Do I need to? No, I don't need to bind that. Should just be I think I need to allocate and then load range. It's been a minute since I've done this because I don't think I have a upload specifically. So let's do an allocate. Index buffer. The size is going to be the size of U32 times chunk LODs sub I index count, which really I don't need to even hold on to. All right, I'll come back to that. So out offset is going to be the address of chunk LODs sub I index buffer offset. Right, so we allocate the memory. I think that returns a Boolean. Yes, it does. All right, so if that fails, we need to bleat about it. So failed to allocate memory for terrain chunk LOD index data. And here we're going to return false. Right. Otherwise, if that was successful, we need to go ahead and upload that data. So let's see. We need to do renderer, render buffer, load range. Right, so index buffer, offsets. You know what? I'm going to create a convenience pointer here. Terrain chunk LOD, LOD equals chunk LODs sub I. We need the address of that. Let's do LOD index counts. LOD index buffer offsets. And then this is going to be LOD index buffer offset. Let's do a U32 total size. Is going to be size of U32 times LOD index count. Right, because we need this more than once, so there's no sense in calculating it more than once. Total size. And then the data is going to be LOD indices. Right. There is one piece of data in here that we actually aren't going to need. And that is going to be index element size. We always know that's going to be a U32 for this. I don't see that ever changing. That should be what we need. All right. So we also need to check this to see if it fails. Right. So we're just going to do the same message, but fail to upload index data for terrain chunk LOD. Right? Okay. So, oh, you know what? We don't want to upload LOD zeros data twice, because that was already done up here. Right? So we don't want to upload that twice. So what I'm actually going to do is change this to a 1. And I'm going to manually set the data for LOD 0. So chunk LODs sub 0 indices equals G indices chunk LODs sub 0 index count equals G index count chunk LODs 0 index buffer offset equals G index buffer offset. All right. No need to upload this data twice. So just copy over these to the first LOD. All right. In theory, this should work. Let's build it real quick. See if I forgot anything. A couple things. No member indices in terrain chunk, line 333. Okay, I must have forgotten to handle this somewhere. Oh, terrain unload. I thought I did this in destroy, actually. Didn't I? I did. Yeah, so let's just do this. Free the LODs there. Okay, so that should be good. All right, now, there is one last piece of this, which is going to be in simple scene, which right now will work, but because we've hacked it a little bit. So when we go to our terrain render data query, I'm going to do I need to do this on both. When we query for the data, and we copy over these things, right? The vertex and index information. Right now we're pulling that always from geometry, and we shouldn't be doing that anymore. So we're going to do a to-do determine LOD based on distance. And for right now, we're just going to hack this and say we want, let's see, chunk LODs sub 0 index count, right? And then we want I'm just going to actually replace this, right? There we go. Element size is U32. Index count, index buffer offset. Yeah. Okay. That makes sense. And I guess we can even say U32 LOD equals 0, right? So that way we've only got that hard-coded in one spot. All right, so we'd have to do that here, and then we're also going to have to do that in render data query here. Whoops, did we already did render data query. I must need the line one then. From line. This is for the shadow pass, which also is going to need to be able to do this. So that's going to live right here. Right, and then we're going to get rid of index count and buffer offsets. For some reason, we're not setting data index element size. 32. Okay. So we're going to use the same vertices, different LOD. So let's build this. Satchel can't hide behind the Trono this time. Yeah, I guess not, right? Oh, that's hilarious. Yeah, it's really funny because I've been following him for a really long time, and that today is the first time I've ever seen him online. Been wondering why C over C++. A couple reasons actually. So some of them technical, some of them preference, right? I prefer it because it's a much simpler language for one thing. C++, especially modern C++, has become seriously bloated and feature creep hell. But C also compiles a hell of a lot faster. It interrupts some things a little bit easier, right? You don't have all the symbol mangling and stuff that goes on with C++. Yes, there's workarounds for that. But it's a combination of that, and then also C++ and Rust share the issue of committees just stuffing shit into the standard library. Exactly. That's I can't stand it, right? And that's the exact issue, right? And most of the features that C++ offers, I don't use, right? I don't use OOP for one thing. Like I don't use object-oriented programming, so I don't need classes, right? I don't need operator overloading, not really. I don't need function overloading. I don't need templates. Don't use those things. So yeah, I mean, that's pretty much the reason behind it. Today you learned that Windows 11 and Mac OS are still written in C. Yep. C is not going anywhere anytime soon. Because as many platforms are capable of having C targeted or C++ targeted against them, it's infinitely more when you consider C. Yeah, maybe you should move to C. I did, and honestly, I have no plans of moving back unless I have to for a job or something. But yeah, I absolutely love C. It's so much easier to work with. And cleaner, I find. Well, see, okay, so that right there, that's another reason that I don't use C++, right, is smart pointers. Because here's the thing. If I wanted the language to manage my memory for me, like a smart pointer, I would use a language that does that, right? Like, if I'm going to use that, why not use language that has a garbage collector too, right? I'm using C or C++ because I want to manage my own memory, not because I want it managed for me. Yeah, it's not so much about judgment. It's just, it's kind of how I look at it, right? Like, why would I use a language that was specifically designed around allowing, bare metal memory management and then just let it manage my memory for me via standard libraries that they added to it. Like that just doesn't, I don't know, it doesn't sit right with me, right? I chose the language because I want to manage the memory myself. Let me manage my pointers, damn it. F lambdas, yeah. What's really hilarious about that is like it depends on the type of programming that I'm doing, right? Like if I'm doing web development stuff, JavaScript, TypeScript, that kind of thing, I use lambdas a lot, right? Because it makes sense there. But like in my C++ or C code, nope. Not interested. Did this build succeed? I didn't pay attention before I closed it out. Okay. So theoretically what we should see when we run this is no difference whatsoever. yet. We'll see if I got this right. Probably not. Wrong. Okay. I wasn't 100% sure that this loop was the way to go. Anyway. LOD. Oh, wow. Okay. There's some rubbish going on here. That is definitely... Well, okay. That actually makes sense because we haven't done that yet, but... Did we not... Did I not set up the actual LODs array? I thought I did. Proper language for proper task. Exactly. Yep. Exactly. I think what initially turned me away from C when picking between the two is simply because C didn't have strings. That was too much for my new programmer mind. I mean, that's fair, right? Although it's not too difficult to build your own sort of string library. Like, that's eventually what I'm going to do. Like, I kind of have my own string library, but they all work with C strings. But I've got UTF-8 stuff in there too, right? So it's... Once you write that stuff once, generally speaking, you can just kind of reuse that code from project to project. Yeah, you can implement your own string or use an existing lib. Yeah, exactly. So like, in my case, I have this K string, right? Which basically has like UTF-8 length, right? We have stuff in here for UTF-8, bytes to code point, all that kind of stuff, right? So we have all the functions here that you would generally need, and then I started actually all the way at the bottom, started setting up a structure, right? What I'm calling a K string. I'm not using this anywhere yet. This is for like higher level like game and application code to use. But in all of my core code, like I wouldn't use this, right? I wouldn't use this structure, right? I would just use C strings wherever I use strings in my core, which is not that many places actually. It's mostly for like reading files and stuff. Yeah, but that's when you're a new, yeah. And rolling your own string library when you're a new programmer is a great way to learn stuff, but a good way to get easily overwhelmed too. Look at glib library. It has all that's missing in C, even objects. But see, I don't want objects, right? I don't use object-oriented programming. Constructors and destructors and all that stuff. Like I don't use any of that stuff. Okay. So, did I forget to create the indices array? Unable to read memory. This is the first iteration of this, I think. Yeah. All right, so let me look up here. That's the destroy. So let me actually relaunch this. Let me make sure this LOD count thing is actually working how I expect. Okay, so we have 5. We can get 5 levels out of this. Out of a chunk size of 16. Okay, that kind of makes sense, right? Comfortable John, thank you for the follow. Appreciate that. Welcome. I will take a look at that glib library because I haven't actually seen that before. So I'll make a note and take a look at that. Let's see. Oh, did I forget to take away the... I forgot to update the TTS guide over on the YouTube side. I'll have to update that. That's out of date. But yeah, there is no... Like the TTS is basically a command like if you throw bits, 100 bits on the Twitch side, or make a, I think it's like a $1 super chat or something, and then send a message along with that. Or I haven't really experimented with the YouTube side, so I don't know if it actually works yet or not. But yeah, the idea is that you get text to speech if you do that, right? All right, so we have ads again. Boy, that went by fast. So for those of you who are new here to the stream, we do have ads that run every 30 minutes for 90 seconds. So I'd like to take that just to kind of pause the stream and make sure that nobody is missing any content. I know over on the YouTube side, you guys don't get ads the same way that Twitch does, but since we get those ads over here, I'd like to pause the stream so that nobody misses anything. And it gives me a chance to hydrate. So it's generally not very long. You know, like I said, it's just 90 seconds and we're already well over half way done with that, so. Almost done with those ads, and then we can continue. Just a few seconds remaining. All right, and ads are dead. Cool. So, so for each one of our chunks, we do allocate the array here. So we have an LOD count of 5. Okay, so the LOD is here. So right now that's all zeroed, right? So the dimension, so if j equals 0, we should be using the chunk size. Okay, 16, that makes sense. So the index count is going to be dimension times 6. So that makes sense. Right, so our index count is going to be 1536 for that first level of detail. So we allocate that. So for the next one, the dimension is going to be 8. That makes sense. So the index count for that is going to be 384. The next one is going to be 4. The index count for that is going to be 96. Next LOD is going to be 2. The index count for that is going to be 24. Yes, that makes sense because it's 2 by 2. Yep, okay. And then the dimension here should just be, wait a minute. So we are on, so the last two LODs are the same. This should technically be giving me 1. Oh, but it's not going to because, let's see. 1 divided by 8 times chunk size. Okay, I'll have to figure that out. That's not quite right. But that shouldn't be causing a crash, right? Okay, so we've got that. So we do that for every chunk. I'm not going to loop through that because there's 256 chunks. When we go to initialize, Let's see. Here we go. We need to generate the indices. Right, so we're initializing the terrain chunk. For each LOD, okay, so this for some reason was failing us. All right, so row is 0, column is 0, I should be 0. Next row is row plus 1, next column is 1. Let's see what these indices are. So 0, 1, 17, and 18. That doesn't seem right. Oh, because it skipped an entire row of... This should probably also be incremented by this. That's part of what the problem is. Okay. I only took that into account for one dimension, right? So, for our next row, we're just saying bump down one row. But if we're at an LOD, like we should be skipping a certain number of rows per LOD. So this should actually be J plus 1, I'm thinking. I'm not 100% sure that's right either, but it's going to be closer to right than we are now. Okay. Let's try that again. Okay. All right, so we'll load this up. All right, so now we should be at 0 and 1 plus next column. Plus J plus 1. Yeah, okay, so this is the first LOD, so we should basically just be operating as normal for this one. Okay. All right, so that should actually be fine until the next LOD, I'm thinking. Let's see. So we have index. That should still be correct, I believe. All right, so in this case, next row is going to be 2. So we have 0, 2. Okay, so it did skip on the x-axis. 34 and 36. So it looks like it did skip ahead here too. And then indices I. So 0. So that looks correct. So why did it... Where is this failing then? LOD count. It must be like off by a chunk ID or something. Let's see. So How far are we into chunk offset X and Z? Oh, it's not that far into the array. So chunk offset X is 1, chunk offset Y, where's that Z? Z is 0. Base position, those make sense, yep. So this is the next row down. And this LOD data is just totally screwed. So why would that be? Let's examine some of the data. Let's see. So Z is 0. This is only the second tile in. So terrain chunks, 256 of them. So the first one, LODs, like that looks reasonable. Second one is foobar. So why would the first one be correct and the second one just be completely garbage data? I've looped something wrong is what that means. All right, so for each terrain chunk, we grab chunk at sub I, that's our iterator, that's fine. Set the vertex count in the vertices, and these look valid. This is where it foobars. Alt terrain LOD count, and we have that here. So we allocate for the LOD count, which should zero out all of that memory. So we have size of chunk LOD. Then we take each level of detail sub j, which is our iterator here. I mean, this logic was working correctly. We verified that. Index counts and indices. I don't see anything wrong here. Right, each index is the size of a U32. Times index count. Like, that's not rocket science here. Interesting indeed. Let's see. Is it Powerline or Airline for NeoVim? I will do one better for you, actually. There is my NeoVim config. it actually takes you to an article describing like everything that I have installed. And I actually did finally update it. So that's got my most recent config in there. It's got everything that I'm using. Let's see. So I guess let me try one last thing. I'm going to put a breakpoint here. I'm going to relaunch. And we're going to take a look at, actually this is going to be chunk LODs. I actually need to go here. Right, okay, so that should be out terrain. And I just want to see if this data is foobar at this point. Yeah, see, it's not. Like that looks legitimate here. And the second index looks fine as well. So something's clobbering it somewhere. So somewhere between here and where we go to initialize it, it's getting clobbered. But by what is the question? So if I go to initialize, maybe if I check it before the first one runs, right? Change this back to a T. See vertex count 289. LODs, like that's still legit. All right, so there's all of let's see, generate indices. So let's skip down to here. Nope, not there, here. There we go. All right, so if we take a look at these guys, LODs and LODs, those are still pretty legit, right? So LOD indices. It's updating this guy up here. Spread this out a little bit. Where's the... Okay. So when we get down here, yeah, see, something clobbered this just then. So this loop is wrong. Something is causing this to overflow. Oh, because I'm doing... Let's see, chunk size. If row is less than chunk size. Nope, that should be fine. Something is causing me to skip beyond where we're supposed to be writing is the issue. I am guessing is going beyond the number of indices. So we'll have to figure that out. All right. Let's see. Do I allocate from a memory pool? Yes, I do. Yeah, so I have a dynamic allocator that allocates right now 2 gigs of memory, and I just divvy that up between everything in the application. I do have a second allocator that's a linear allocator that gives me frame-specific data, every frame that gets reset. So any allocations that need to happen in the middle of a frame, allocate from that one because it's a linear allocator, so it's super fast. So the overhead of getting memory from there is basically almost nothing, essentially. But yeah, that's kind of the way that works. All right, so I think I know where the issue. Well, I know where the issue is. I don't know what the problem is right now, but this is where I'm gonna have to stop it for tonight because I do have to work in the morning. I'm gonna put a left off comment. This is clobbering memory into the next chunks somehow. Double check the config or the loop. All right. Let's see. So I think I'm not going to check this in tonight because this is going to break the branch, right? We're on this terrain chunk branch, and that branch actually does work right now. So I'm not going to check this in until we actually fix this issue, right? So, all right, let me see who I can raid. Oh, Spiro's still online. I'm going to raid him. No brainer. All right, so for those of you who don't know, Spirodon is a pretty awesome dev. He's working on some really cool stuff regarding. He's actually using Zig and targeting WebAssembly, and then using the HTML DOM as his front end renderer because he's a madman, and I love it. So we are going to raid him because he's an awesome dude, and I like what he's doing. So I will also drop a link on the YouTube side. Let me just pull up his stream real fast so that you guys can check him out if you want to. And yeah, that's going to do it for tonight. So if you haven't already, follow me on both sides, over on the YouTube and the Twitch side. And I appreciate you guys. And yeah, I will see you guys on the next stream. See ya.